So someone's looking to lake. So this is the last I'm going to do. These were the depths.
What number is this?
Oh, this is number 10. I only take a second one because there's 8 data. Alright, and we'll talk about verifying the request. Alright, there's 8 data. And they looked at the depth at 2 different times. I'm going to write this as initial depth. And then depth 5 years later. Won't take too long. We'll just enter the 8 data and we'll look at these differences. Okay. They wanted to see everyone, someone wanted to check whether or not the clarity in the lake was improving. So how do they do this? They use something called a Secchi disc. And all it is, it's a disc, drop it with like a little rope thing, right? Drops in the water, and they keep dropping it, keep letting it drop and drop and drop until they can't see it anymore. And then they pull it back up, and they measure the what?
The height.
Yeah, does that make sense?
Mhm.
So they just keep dropping, I can still see it, and then I can't see it. Anybody ever been to Six Flags? Yeah? You know what it used to be called in the 80s? It's called Wild Roll. And I lifeguarded there, everyone. So at the beginning of a day on like a Saturday, it was crystal clear, it was just crystal clear what? Blue water. But guess what it looked like around like 5, 6 o'clock? After, just all of us. We get in the water, myself, my friend, all the lifeguards, everyone else, sweat and all that. Even though all the filters were running, what would happen to the clarity? Yeah, it wouldn't. But then, after when we left that day, it'd clear up again. That's part of it when people drop money out of their pockets. And that's how I made my money. I got like $3 an hour, but you just go on the bottom of the water, with your goggles. I'd sometimes collect $20 and stuff. To me, that was like $1 million back in the 1980s. $20! Wow! Because no one can see it on the bottom. Does that make sense? Anyways, the second disc, and here come all the depths. I'll write them down. This won't take long. All right, the depth was 38. Ooh, 5 years later, everyone, it was a depth of 52. So it sounds like they were working on stuff, making sure no one was putting, in terms of waste, things like that. They allow boats in this lake. 65, 72. Or, I don't know if these numbers were made up. No, this has a source. This does have a source. 65, 72, 74, 72. 56, 54. 36, 48. 56, 58. And lastly, 52, 60. All right. Alpha level is 5% level significance. The sample size this time is what? 8. But everyone, in this problem, they didn't give us these. But, everyone, for this problem, what do you all think? If we're doing, do you want to do, how about we'll call this y? We'll call this x. Everyone, how about the difference? We'll do y minus x. What would be our alternative hypothesis? Want to know if the depth is improving. So that would mean, everyone, it should go deeper. It should go deeper until we can't see anymore. So this should be deeper than this, if that's our alternative hypothesis. This being
Greater.
larger depth than this right here, then this difference should be greater than what? 0. So that's going to be, I'm going to use the same alternative right here. Alright, so I'm going to do y minus x. Depth 5 years later minus initial depth. But our difference will be that. Cool? Sample size 8, we'll get this. Everyone, we can assume that difference data are normally distributed. We'll get our p-value, and then we'll talk about what we're doing, whether or not there's evidence or not. I'll get this out of here. Are you ready? This will only take us a couple minutes. What takes the longest? Putting us in what?
The data.
L1 and L2, that's all. So here I go. I'm going to go back to my calculator. The first thing is, I'm going to go to the stat button. Edit. I'm going to go to L1 and I'm going to what?
Erase.
Clear.
Clear.
Up there at L2. Clear. I don't even have to clear at L3. but you might do it just for fun. Hey, let me clear it out because I'm going to enter something there. But here we go, 38, 58, 65, 74, 56, 36, 56, 52. Next row. 52, 60, 72, 72, 54, 48, 58, 60. That's good. Yep, we're good. Do I do anything here? No, I go to a blank screen. Clear. And I'm going to say what? So when I want to do y minus x.
L2 minus L1.
Very good. I put these in L2. So I'm going to do L2 minus L1. Second 2 minus second 1. Store, STO, store button. And L1. L3.
L3.
Which is second 3. Enter. Oh, thank you. Isn't that cool? Yeah? I'll go to stat. So far, so good? Oh, let me go back. I don't want to rush anybody.
I had a negative.
Did you see that negative in there?
The first 3 are negative.
Yeah, she was the first thing. Let me look at those.
You're
Stat?
Did you do L1 minus L2? Or L2? It's L2 minus L1.
And let me be clear why we're doing L2 minus L1. We want to look at, we took the depth 5 years later, subtracted the initial depth, and we're thinking that the depth should increase, so that should be higher. So she's going to just go back to a blank screen and type. And when I'll go back, this is what she's going to type. She's going to go L2 minus L1, store in STO, L3. Now let's go have some fun. Stat, where am I going? Tests. Always go to t-test when you're doing matched pairs. For inference, it's about 2 population means. It's matched pairs. This is always 0.
Don't
But
you
let me
do
go back
data?
here. I want what?
Data.
Because I don't know these numbers yet. I'm using data, right? And I don't know, so I'm going to hit data. All right. All right, you're 0. Which list am I using?
L3.
L3. Frequency is always 1 for 1 row or 1 column. And then which one of these do I want? Greater than, right? Someone's saying, no, like this minus this should be greater than 0. Y minus x should be greater than 0. And calculate. Ooh, that was a close call, but I want to see the p-value. Woo! It was close, but we've got evidence. P-value is 0.02 what? 4. This was what? 2.38. You go, hey, you never got T-crit. I'll get that. What's the conclusion? There is sufficient evidence suggesting this is greater than 0. I would like to show why this is occurring, everyone. So I'm going to get the T-crit. That'd be inverse T 0.05, comma, what's the degrees of freedom?
7.
I do want to point out one. We can assume that difference data are normally distributed. They told us that. If I had an extra minute, I'll show you something. I'm going to show you the box plot. So I'm going to find this T-crit. What do you get?
1.89.
1.89? 895? That's off the table? Off the table. Or you can do this on a cool new calculator. Because it only takes a second, I do want to show you something, everyone. I'll hit the light and I'll put it back on. I know a lot of you are copying. I should look at that box plot. And it only takes a second, doesn't it? I really should. Make sure there's no outliers of the differences. So I'm going to go to second stat plot. And I'm just going to look at this. Zoom what?
9.
Zoom 9. It's on L3. Any outliers?
No.
Roughly bell-shaped? Check. Good to go. All I need is a normal probability plot, but I don't have that software. Just didn't show this. Pretty cool. There is evidence that the lake is actually what? Improving. There was a source on this. And when the source was someone from Joliet College, that's where the author teaches. That's where the author teaches. So a lot of this stuff was done there. Super job. Okay, next class we'll do the last section. Independent samples. So then we'll do a 2-sample test. Then the following class will be for the final. Have a great day. Super job, everyone.